have to do is send to somebody the STMX file. Otherwise, stay away from it. Alrighty, so back to our model view here. So let's say we want to zoom into our structure and we really want to show population. We have this weird thing down here. You know, what's this? This lets us change the registration point of the window into the model. You know, so it lets us center our structure appropriately within the interface page. So we can say, oh, you know what, this is a little too zoomed in, so let's zoom out a bit, and let's, you know, I want population in the lower right, or I want population in the upper left, or I want population. This lets us kind of find our bearings within the model. Then there's this option here, this cryptic. Don't allow user to change visible region. If you have a giant model with lots of structure and that's spread across a large amount of space, you could imagine that you would allow people to scroll through it. So let me get rid of that dumb slider here. Okay, so now, you know, I can scroll through this stock and flow structure. But if you have a really, really big model, and you allow the user to change the visible region like that, your interface will get slower. Big models are expensive to render on the web. So I tend to try and suggest not forcing scrolling on the user. Try and present the piece of structure you want to present within a window without people having to scroll. Scrolling is typically a bad thing.
I'm sorry, Billy, can you say again? So you are advising us not to uncheck that box.
Right. Yeah, because most of the time when you're showing a piece of stock and flow structure, you don't want people to have to scroll to find the piece of the stock and flow structure that you want to specifically show them. If you want to show them the stock and flow structure, zoom in on that piece of stock and flow structure that you want to show them, and then don't allow them to scroll around. There's benefits. One, they see what you want them to see, and they don't see what you don't want them to see. And the other benefit is it's a lot quicker, because that means I don't have to take your whole stock and flow structure and translate it into something that works on the internet. Because like I said, the whole point of this model layer here is to make interfaces that work online.
Which means that if we have this check, that means the presenter can zoom in and out anytime he or she wants.
Right, so I can zoom and do whatever I want here, but when I'm presenting the interface, that's all I see. There are no scroll bars. That checkbox controls whether or not the scroll bars are visible.
So what if the task is to find population in the model?
Then, yeah, you need scroll bars. But that's a weird task. I'd say that doesn't fall under the normal use case. So tools like this brings me to a point. Drag and drop tools like this are all designed around covering 80% of the possible things you would want to do. Yeah, there are lots of things that you could do that this tool can't do. This tool, though, does actually have the ability for you to expand it with custom code. And if you're interested in that, that's something that I can show you next week in the lecture format. But for now, that's probably too much. But anyway, these tools kind of limit you into what you can do, because you can only do what the designer of the tool has thought and allowed you to do. You can't just do anything in the world. Okay, so now we've talked about all of the annotation widgets. You know about the graph. Let me show you the table real quick. The table is exactly as the table is on the model layer. So something kind of important to remember with tables, especially on the interface, is if you have a time step of really small and you have a really long simulation time. So let's say you've got a simulation time of 30,000 seconds, and you have a time step of half a second. That's 60,000 data points. If you put that in an interface, people's eyes are going to glaze over, and they're not going to pay attention to a gosh darn thing you're showing them. So with tables on the interface, make sure you're not presenting an overload of data, because oftentimes on the model, you're using tables as a modeler to debug your model and figure out what's going on. users of your model aren't trying to debug your model. The only one who cares about that much data on your interface is you. So that goes back to your audience. When you're designing your interface, design it for the people who are going to use it. Yeah?
I have a very interesting counterexample of that.
Oh.
You remember I was talking about the Ridley model, the one where I totally failed in presenting stuff. So here I am in Germany, and I'm going to talk about Germans, right? So these young people, and all they've seen in their whole life are spreadsheets, right? So I presented these beautiful graphs with beautiful pictures, and I think this must be very, very nice and very attractive to them. They didn't want to see the graphs. They were not used to see graphs. They were used to seeing numbers. So they wanted everything in tables. You figure.
Know your audience. Yeah, so tables work just like graphs. You put stuff in them. You make them comparative. You can change where time is. At the bottom here, you have control over intervals. These reporting options stink. They're really confusing. Kind of a legacy issue here. And this all has to do with when your interval doesn't match your DT and you have flows, we do math behind the scenes to sum stuff up so that it appears as if your model had the DT of interval. So, if you have a stock and a flow and an inflow, let's say your model's running for one time unit, your DT is 0.25, and your flow value is 5. When you run it, you're going to get 20 in your stock at the end. So if you were to show this table by every DT, for flow 1, you would see 5, 5, 5, 5. But if the interval for your table is 1, the number 5 is incorrect, because the flow over that time period wasn't 5, it was 20. We need to sum up all those 5s. So let me actually do that. I'll show it to you. Because these table options, while really annoying, are unfortunately important. Okay. And I'm just going to do it on the model layers. Same thing. Stock, flow. Okay. And then 13 times 4. Okay. So, if we were to look at this table, we see that there are 5s here. Whereas if we were to sum this, show the values accumulated over the interval, hey, it should have accumulated.
Isn't the stock already the accumulation of flows?
Yes, but this means accumulating it over the interval.
Option just fell out.
Yeah, it's weird. I don't know. I will look at that. That's strange. It should have accumulated. What happens if we do it with DT? Yeah, that's doing it wrong. Okay. Well,
Because there is show flows accumulated over interval.
yeah, and that's what I was doing. And it's not doing that. No, it's doing it the other way. If you actually notice, it's dividing. Whatever. All right.
I'm not going to mention any names now.
Okay. So anyway, tables.
But sorry, you had the interval of 1, right?
Yeah.
Yeah, you have to
No,
So maybe you
one
have to change it there, right?
Not a DT DTO 1/4.
I did have a DTU.
But, okay.
Whatever. I'll look at it. I'll figure out what's going on, and I'll explain it tomorrow. Okay. So where was I? Tables. Okay. Numeric displays are just an instantaneous value. So this lets us look at a point value. So we can see population at the current time. And so by default, numeric displays are pretty ugly. They look pretty old. But you can make them look a heck of a lot better. So you can make them transparent and they look like that. Or you can do this, which I think makes them look a heck of a lot better. It separates them out and makes them look more table-y. If you make it totally transparent like this, and then you actually can come in here. Oh, that's a new option. I must have. No, I didn't. Show title. So you can actually just get a number, and you can make your own label for it as well. So oftentimes we'll do this. And again, legacy for why the numeric display looks like the way it does. This is a status indicator. It's the traffic light. It shows red, green, and yellow based on the value of a variable. So we can say, as the population gets larger, move the traffic light from green. So everything between 0 and 50 is good. Everything between 50 and 75 is yellow. Everything above 75 is red. So now when we run this model, the traffic light goes from green to yellow to red. This checkbox at the top lets us flip the value judgment. Because by default, people assume red is bad, green is good. So here we're saying that 75, high populations are bad. We can flip it around and we can now say that high populations are good. That's all that checkbox does. Okay, so we know our input devices, we know our sliders. I'll show you the knob. Knob's pretty much the same exact thing as the slider, except it's over in a circle rather than a straight line. So the minimum for the birth rate is 0, the maximum is 0.25, an increment of 0.1. And what's nice about Architect is that I can, interval is 0.01. Because when I change things, I can have two controls for the same variable. So the birth rate is being controlled by both the knob and by the slider. When I change the knob, the slider updates. That can be really, really useful. So for instance, let's say you want a slider, but you also want people to be able to type in a number right next to it. You can put both those controls down at the same time, and they will update together. All right, we've talked about the numeric input. Let's talk about the switch. The switch allows us to turn variables on and off, 0 and 1. So oftentimes you'll have a policy switch. Turn on the disadvantaged youth policy. Turn off that policy. You need to use a switch to do it. The switch is on whenever the value is not 0. The switch is off when the value is 0. All right, options. This is just a series of chained switches. So let me add some variables like that to this model. Okay, so converter 1 is on. So switches are chain switches options are used for mutually exclusive choices. So I have converter 1, which is on. These other 4 are off. I go back to my options. I can add an item, converter 1, add another item, converter 2, 3, 4. Okay? So you'll see that only one of them is turned on. I can then control the way that this thing looks. I can say put them vertically, put them horizontally, and you'll see that they automatically reflow to fit the box. And the other choice you have is as a button bar. So as a set of, boy, this thing's a mess now. As a set of toggle buttons. So when I come here, converter 1 is now set to 1. Converter 2 is now set to 1. Converter 1 is now back at 0. Converter 3 is 1, the rest are 0. Converter 4 is 1, the rest are 0.
So they're either 1 or 0s in the model.
Yep. Yeah, it's used to turn things on and off. Or you could use it to collect, the answers to multiple choice questions. What do you think, 2 plus 2 is? And you could have each one of these converters represent an answer. 4, 6, 1. And you'll see in your model that the variable chosen will be 1, the rest will be 0. We have this, which is called a list input device, or a grouped input device. This lets us control many things at once. It's a tabular input. So you see here that some of the items here are blank. That means these are things that have equations. So let me put a slider down, for instance, on births. Okay, in this model, births has an equation. What I can do is I can put a slider down on births or a lid that controls births, and you see you get this weird tilde button. So tilde means use the equation or don't use the equation. So right now I'm using the equation. Now I'm not using the equation, and I'm going to use whatever the heck this slider says. So if you change the birth rate, it'll have absolutely no effect because the equation for births is always going to return 50. So when I change the slider, the value changes in the group input device. I can change this. It'll change it down here. So this group input device is used to enter in lots of data at once.
But there's no tilde associated with the input device.
Right, it's just blank. So if it's going to use the equation, if you want it to use the equation, you just blank it out.
You blank it out. Okay.
Blank means use the equation. I thought that was more understandable than this weird tilde button, because tilde means nothing to regular people. If you don't tell people what the heck tilde is, they'll have no clue. So that's why I tend to not set these kinds of devices up in my interfaces. I always try and make variables be constants that I want users to control. Where this really begins to bite you is when you have arrayed models. So arrayed models is you have the same piece of structure, and you're, rather than relaying it out twice or 3 times or 100 times, you lay it out once and you say, calculate it with 100 different initial conditions. You end up getting cases where by default you're going to want to get this tilde button, and it's annoying. You'll see that later in the week, because the model that we're going to build this interface on top of is an arrayed model. Okay, and then a graphical input device allows us to control the shape of a graphical function. So it shows us a picture of what the graphical function looks like, and when we press this button, it shows us a draggable graph so that we can change the shape of a graphical input function. Phew. Alrighty, that's all of our devices. So now you know what all of the possible things you can put down are. Do people mind if I go over by 10 minutes? Okay, I'm going to go over by 10 minutes. The next really important thing for you to learn about is stories. Stories are a tool that we use to explain model structure to people who aren't familiar with either the model or system dynamics. It's a really nice way of presenting a stock and flow structure without having to have a lecturer in front of a group of people telling them what all of the symbols mean and how they all relate together. It lets you progressively reveal the contents of your simulation and annotate it as you go. So let's build a story together. To start a story, we hit that strange context button, and we hit Add New Story. And it says, hey, Billy, what story do you want to name it? And what module do you want to start this story in? Do you guys have experience with modules? Slight. Okay, so you know what a module is. It's kind of a submodel. So you can build stories that start in one module and end in another module. So I just need to know where you want to start. In this case, it's really easy because we only have one, so there we go. Alrighty, so you should recognize this picture. We played with this already. This is the model view widget. Stories are composed of a progressive series of model views. So in this story, I want to explain to people how carrying capacity works. So the first thing I want to do is I want to put down population. And I want to annotate population. I want to tell people, this is the group of critters we are studying. I'm going to add a new page to this story. And on the next page of this story, I want to select births. And here what I'm going to do is I'm going to say critters are born and added to the stock of population. Okay? So let's take a look at what this story looks like. So this is the group of critters we are studying. And then we can use either the arrow keys or the space bar to change the page. Critters are born and added to the stock of population. So we're kind of building like you would in PowerPoint, a progressive animation where we reveal more and more things. Alrighty, so let's keep going here. And here we say, oops. So I made a mistake. I only showed a single connector. I wanted to show more than one connector here. So oftentimes, your page is going to look like this. Let me select nothing here. And you're going to see this interface settings. You're going to say, oh my God, I screwed up. How the heck do I add something else to the page? You have two choices. You can either scroll down and hit Edit Story Items, where the easiest is to double click and hit Change Visible Variables. I want to show not only that connector, I want to show this connector and the birth rate. So now we can annotate this portion of the story and we can say, critters don't come out thin air. The more population we have, the more critters will be born. And now, because we've begun to explain what the symbols are, we can quickly start adding in more structure. So we can say, critters don't live forever. They die, decreasing the population. We keep going. We get the rest of it, and we say crowding is one of the main causes in this model of critter death. If there are too many critters for the land area they live on, They die competing for resources. So now we've got, this kind of full progression which explains, what's going on here with this stock and flow structure. So we've kind of explained to people what's going on in our model. But what we haven't done is done any relationship between this structure and the behavior of the model. So what we need to do is we need to put down a graph. So one of the nice things that you can do about stories now in Architect is you can put widgets down in the story, directly in the story, and not have to put them down in the model layer and show them from the model in the story. It keeps your model a lot cleaner. So what I want to do in here is I just want to plot population, because that's, the variable under study here. That's the one we care about. And I'm going to put a run button here so that people can run the model and see the results. Okay, so we come here, they run. And you say, well, Billy, that's not the behavior of this model. The model doesn't produce these results. Storytelling is really awesome. Storytelling allows us to do partial simulation. The only items that get simulated in a story are the items that are visible on the screen. So population here is flat because there's no inflow or no outflow. Population is flat in that case. So this all of a sudden becomes a really, really powerful tool for explaining how structure affects behavior. So let's keep doing it. Oops. So let's go to the next page. Oh crap, my graph and button aren't here. So now I gotta go and I gotta take this, I gotta select them both, copy them, come to page 2, edit, paste. And I'm showing you this technique for a reason. This is not the right way to do it. But what's really important to realize here, if you don't actually click before pasting, it will paste items exactly where they were on the previous page. It's really useful if you want to kind of move stuff around across pages. If you want to do that, don't click before paste, because otherwise stuff kind of shows up wherever based on where you clicked. Just hit edit paste, and it'll go wherever it used to be. So now, I can come here, and I can run the model on this page, and now we have dynamics. Okay, so births affect population, and we have a constant linearly increasing graph. It's because we don't have any of the structure that population uses to affect births. Population right now has no effect on births. The value that we use for births, and keep this in the back of your head when you're building stories, the way that we substitute values is based on the initial value of the variable when you run the model as a whole. So when we hide stuff out, we use the initially calculated value to determine what the value is going to be when we hold stuff constant when doing the partial simulation.
So that means if the initial value of population is 25 and you have 0.1 birth rate, it's 2.5.
Yep, and it will just only use 2.5.
Okay.
So you can use that to kind of control what results you get in story. Alright, so let's stop doing this really annoying cut and paste and paste and paste and paste until we're blue in the face. So let's delete this, and let's use a feature called templates. Templates are like slide masters in PowerPoint.